is the 75th anniversary of Project Diana. And at 11:58 this morning, at the exact same time that the original moon bounce was done, we expect to bounce a signal off the moon. And with that signal, you can send your voice to the moon and back and travel 500,000 miles. The schedule is as follows. At 10 a.m., I am giving this introduction. 10:30, Dr. Daniel Marlowe of Princeton University will speak about the TLM-18, which is the antenna that we have on site today. That antenna gives us the ability to look at pulsars, other galaxies, interstellar space. We can monitor weather satellites and download information that allows us to generate an image that tells us where hurricanes are. Then Ray Chase and Al Clace at 11 o'clock will reveal new information about Edwin Armstrong's contribution to the success of Project Diana. At 11:58, that's when we intend to do the first live moon bounce over Zoom. And I'd like to be able to bounce everyone's voice. If we have many, many participants, we have a second Zoom meeting that you may be able to go to in order to bounce your voice individually. At that time, when I do the moon bounce at 11:58, I will ask everyone to send their voice to the moon at the same time so that you know that you've done it. At 12:15, Cindy Stodola Pomperlo, who is the daughter of E. King Stodola and is debuting her new book today, which is available on Amazon, will speak. The book is To the Moon and Back, The Life and Times of Project Diana. I am so looking forward to hearing her speech because these guys were regular men and women who came to work every day, had regular lives at home with families that needed to be attended to, and I think that that's a really important thing. They did great groundbreaking work and had normal lives at the same time, just like us. At 1 o'clock, Fred Carl will speak about space exploration after the moon bounce. After all, the moon bounce was the beginning of space exploration. And he'll talk about the big ear. At 2 o'clock, Charles Sabula will speak about Dr. Walter S. McAfee, a hidden figure and pioneer of radar. Without his mathematics, it would not have been possible to calculate for any point on the moon from any point on the Earth, and thereby compensate for the Doppler shift. Diane Mercedes McAfee, the daughter of Walter McAfee, will speak afterwards, and they'll take your questions after 2:30. At 3 p.m., we'll see a video that Frank O'Brien has prepared for us. It's called Radio in Space Communication, because the radio that we used in 1946 for the moon bounce is used today and will continue to be used in space exploration throughout time. So let's begin. This is the Zoom meeting information for the second meeting. Please write down or take a screenshot of this so that you have the meeting ID in case you want to bounce your voice individually through another Zoom meeting if we have too many people at 11:58. And let's start. InfoAge is a nonprofit organization, and our mission is to preserve science and history. So please donate. This is a free event, and the moon bounce is a free event through the FCC. But let me tell you, we need help. So please consider donating to InfoAge. There's a great link at the bottom of this page. Use it if you possibly can. Thank you. Project Diana. Bouncing a radio signal off the moon was the first attempted by John DeWitt in 1936. From what I understand, he did not succeed because of several things. There was a pulse transmitter that they dubbed the ice cream freezer. The experiment failed because they did not have sufficient transmitter power. Here's a photograph of these guys trying to make this happen. And it kind of does look like an ice cream maker, doesn't it? However, in late 1945, following the end of World War II, scientists at Camp Evans began to work on a way to prove that we could pierce the ionosphere, not only from the Earth, but also from above the Earth. And that was the important thing. Imagine a human race never having heard a radio signal transmitted from above the atmosphere. Could we possibly be that isolated? Was there nothing out there that could send a radio signal? This is something that had to be answered. Mathematically, we knew that it was possible. We thought that it was possible. But unless it's done, it doesn't happen. Project Diana, named for the Roman goddess, was initiated using radar equipment developed during World War II. Here are the men of the 1946 Project Diana team. There were Lieutenant Colonel John H. DeWitt, he was the project leader, E. King Stodola, Dr. Harold D. Webb, Herbert P. Kaufman, and Jack Moffinson. We're lucky enough to have been in touch with all of the family members of these men, and they have wonderful stories to tell us about the lives of these people. Here they are. This is what the Diana site looked like in 1946. You can see that there are all sorts of things. There is the SCR 271, maybe the 272 in this picture, and there's a smaller antenna. There are small radar trucks. And this site was basically used specifically for radar research. It was the Army Signal Corps area. The roads were barely made at that time. And if this picture were a little bit bigger, you could see that across the way along the Shark River, there were no buildings. There was nothing here. This is where the first moon bounce was done. Here we have the SCR 271 and the story. Look at the truck. I'll tell you that it's 1946. So the SCR 271 was not sufficient to complete the moon bounce. Imagine going to work every day and trying to do something like this and failing day after day. You make your lunch in the morning, you get in your car, you drive over, you try again. It didn't always work. It didn't work at all until January 10th, 1946 at 11:58 in the morning. We'll learn today about what the things that did happen that were making the moon bounce possible and how everything that was learned along the way made it happen. This is the kind of equipment that was being used at that time. And there it is. The SCR 271 had an extended bed spring, and they thought that that would help, and it did. And due to the precise frequency control that was required, we needed a special transmitter and receiver. And it was Major Edwin Armstrong who was able to create that kind of transmitter. I understand that his transmitter is still being used in some ways. Transmitted power was 50 kilowatts at 111.5 megahertz in 1/4 second pulses. Look at the equipment that was used then. Dials, handles, wires everywhere. Today, the flick of a button or two, we do the moon bounce. This is Colonel John DeWitt. There's a newsreel that's available on YouTube of John speaking about the success of the moon bounce. And he says something like, before now, we didn't know whether we could communicate with anything above the ionosphere. Now we may be able to build spaceships. When I watch that clip, I think about people who say that things are impossible to do. And until the moon bounce was done, it was impossible to think about building a spaceship. What is it today that we think is impossible? But if we have the technology, will definitely be possible in the future. This is what the return looked like. You can see the original signal being sent, and then you can see that the signal has gone 238,000 miles and returns back. It was called the Echo. We learned that the moon's diameter was 2,159 miles at a speed of light of 186,000 miles per second. The ionosphere covers the Earth 38 miles up, and the thickness of the ionosphere is 250 miles. There was a comic strip that was created by Harold Webb about the moon bounce. And if we went ahead and read each of these pieces, it would be very difficult to watch our time. However, this comic strip was published and is very, very interesting. People laugh at us now, he says. One of the team members, Dr. Harold Webb, became the father of a daughter in January 1946 and promptly named her Diana. I have a statement that I'll read about what Diana wants to say. She's not able to join us today, but she did give us a statement. Dr. Webb also created a comic strip depicting Project Diana experiment and went on to predict interplanetary space travel, missile development that eventually came to pass. These people were visionaries. They saw things that others didn't, and they weren't afraid to try, and they weren't afraid to fail along the way in order to achieve the great thing that they did. Dr. Webb went on to an illustrious career in radio astronomy. Dr. Walter McAfee was a civilian astrophysicist, and his mathematical calculations were vital to determining the expected Doppler shift. He also calculated the reflectivity coefficient of the spherical moon to establish other technical parameters. Without Dr. McAfee's help, the moon bounce wouldn't have been possible. And here is a picture of Dr. McAfee as this, I guess, plaque or road sign was dedicated to Project Diana. The birth of radio astronomy, the beginning of the space programs, Earth-Moon-Earth transmission that ham radio operators around the world love to do if they have a big enough antenna and radio. The ability to send a signal from one part of the Earth to another part of the Earth using the moon. The ability to explore space. And this project, of course, was the beginning of the tradition of naming space programs after ancient Greek and Roman gods. You can think of Mercury, Gemini, Apollo. This is the QSL card for the moon bounce. And I think that ham radio operators understand what this means. It is a confirmation that it was done, and it was done here at Fort Monmouth, New Jersey. And if you're not sure whether this is true, here it is. Contact with the Moon, made by radar, New York. It was pictured at the Institute of Radio Engineers Convention at the Astor Hotel on January 24th, where, there they are, the names of the people who were involved. Colonel John D. DeWitt, head of Project Diana. Scientific history was made on January 10th of that year at this laboratory. And it was the birth of frequency energy shot directly to the rising moon. And it was returned 2.5 seconds later. And we cannot change that because today it takes 2.5 seconds for the signal to be sent and heard back. Thank you for viewing. If there are any questions, this is a great time to ask.